Hello everyone. In this video we're going to be solving an algebra problem. We have 7 to the power 6 minus x equals x plus 2, and we're going to be solving for x values. Now this is a non-standard or transcendental equation because we have an exponential function on the left and a linear function or a polynomial on the right hand side, which means you cannot solve this analytically. Okay, one of the things we can do is we can look at the graph of these functions and try to estimate and then kind of test it out, or as I'm going to show you with my first method, we can also use a special method, which is very special, by the way. So let's go ahead and explore that first. So we have this expression 7 to the power 6 minus x equals x plus 2. Let me tell you, first of all, what the goal is so that you know where we're going with this. So our goal is to use a special function called Lambert's W function. And what it does is it takes something like this, t times e to the power t, and it just turns it into t. In other words, if you think of a function f, such as f is t times e to the t, then w would just be inverse of f. Make sense? Because that's what it does. Since we can't express it explicitly, we're going to have to just call that w. Okay? So we don't know what wx is, but we do know what w x times e to the power x is. Does that make sense? I hope it does. Now, how can we put this expression into that form though? Well, let me go ahead and talk about a simpler case first so you can understand how this is working. For example, if you had something like 7 to the power x equals x, which doesn't have to have solutions, by the way, or actually I can probably make it a little easier for you. Maybe something like e to the power, and I kind of need to think about this. E to the power x minus 1 equals x. I don't know if it's going to have solutions, but I think this is good for our purposes. So the first thing I'm going to do is, my goal is basically to put this expression into something like this, t e to the t. To be able to do that, we need to bring this exponential and the x on the same side. To be able to do that, now it's not going to work if you divide both sides by x, because that's going to give you 1 over x, which is something you don't want unless you have e to the power 1 over x. Of course, if you have something like this, it'll work because it's in the form of t to the t. Oops, I meant to write e to the power 1 over x, right? Something like this. This is going to work, but that's not what we have. We have e to the power x minus 1. So here's what we're going to do instead. We're going to keep the x here and bring the e to the x minus 1 over. Actually, we don't have to bring both. So let's do this first. I'm going to go ahead and write this as e to the x divided by e first. And then I'm going to cross multiply to make things a little easier. E to the x equals ex. But by the way, I'm hoping that you can see what the solution is going to look like at this point. But don't worry about it if you don't, because I'll show you. So my goal is again to bring these two together. But in this case, we have to bring the e to the power x over. And of course, e needs to be on the other side. So we're basically going to switch. To do that, we're going to divide by e times e to the x, e times e to the x. E is going to cancel out, e to the x is going to cancel out, and we're going to end up with something like this. X divided by e to the x is equal to 1 over e. And again, this may not look, well, if this doesn't look meaningful, I don't know what can, right? At this point, it's probably very easy to guess, but again, let's just pretend we cannot guess the solution. And here's what we can do. We can write this e to the x as e to the power negative x because it's in the denominator. And 1 over e, you can just probably write it as e to the power negative 1, or not sure. Yeah, you can write it that way. Now, here comes the best part. We're going to multiply both sides by something so that we can take advantage of the Lambert's W function. And that will be negative 1, because notice this is our t, and you do need a negative x here, but you can't just come up with negative x. So what we're going to do is multiply both sides by negative 1 and negative 1. Now, this is what we exactly want, negative x multiplied by e to the power negative x, which is in the form t e to the t. But here, we don't have that, so we're going to write it as negative 1 times e to the power negative 1. Now, when you apply w on both sides, and we kind of need to move this a little bit so it can fit the w there. So we're going to go ahead and apply w on both sides. Let's just use big parentheses. Oops. Like this, and then like that. I'm going to put the w here too. And of course, they're supposed to equal, right? Cool. Now, what is that supposed to mean? When you apply w on t to the t, you get t. So this is going to give you negative x. This is going to give you negative 1, which means x equals 1. So such a roundabout way to do it, right? Obviously. But I just wanted to show you how Lambert's W function works so you can hopefully test it out with this problem, okay? And the problem is 7 to the power 6 minus x equals x plus 2. But Houston, we have a problem. We have a lot of problems, actually. The problem is we don't have e to the x or x. We don't have just x. We have x plus 2. Guess what? We're going to try to take care of that by using a super duper method. You know what it's called? Starts with S, substitution. Yes, that's one of my favorite methods. So we're going to go ahead and call this expression t. You can call it u as well if you want. Let's go with u because eventually I want to use the t for t e to the t form so I can stick to it. As you know, if you apply Lambert's W function to this, you're going to get t from here. That's why I'm looking for that. Now, by replacing x plus t with u, you're basically assuming that x can be written as u minus 2, right? Because x plus 2 is equal to u. Now, we're going to replace this x with u minus 2. So it's going to be 7 to the power 6 minus u minus 2 equals u. Now, this is definitely better than the original one, but let's simplify this. 7 to the power 6 minus u plus 2, which is 8 minus u. And that is equal to u. Now, here's what we need to do. We're going to need to bring these together. But first, we need to separate this. You don't want something like 8 minus u. You want u with u, okay? Hopefully, you know what I'm talking about, right? So here's what we're going to do. We're going to go ahead and separate these two things like this, and then cross multiply. I think cross multiplication would be awesome here. When you do, you're going to get u times 7 to the power u, and that's going to equal 7 to the power 8. In this case, there's actually a really easy way out, but we're going to stick to Lambert's W. That's why we want to use that. So here's how you can do it, though. We don't have e, but that's okay, because 7 can be written as a power of e. How? E to the power ln 7 is 7. Make sense? And this is true for any number a, as long as a is positive. Oops, I meant ln a. So you can write a as e to the power ln a. So this is what we're going to use. Replace 7 with that. E to the power ln 7 to the u equals 7 to the 8. And then we're going to go ahead and distribute this, but it's going to look like this. U times e to the power u ln 7. It's better to write it that way. Trust me on that one. Equals 7 to the 8. Now, the left-hand side is almost ready. The only thing we need to do is multiply both sides by ln 7, because you want this to be your t, right? Hopefully. It's going to look like this. U times ln 7 times e to the power u times ln 7 equals 7 to the power 8 times ln 7. Beautiful. Now, we're going to go ahead and apply Lambert's W on both sides. And when we do apply it on the left-hand side and on the right-hand side, like this, right? We could space it out a little bit, I guess. It's too crowded. So let's go back up a little bit. Oops. And then let's go ahead and move this whole thing first to the left. And then separate these two things, maybe like this. Oops. And then even move this one. Okay, awesome. Now, we're going to use W on both sides, so we make sure that there's enough room. Here we go. Great. Now, the left-hand side looks really good because this is your T, right? They're the same. Notice that. Okay, sorry about the noise. It's coming from outside. I don't have any control. But when you apply it, it's just going to be U times ln 7. But on the right-hand side, we're not really getting something like T e to the T form, right? But we're going to do some manipulation. So let me go ahead and leave it like this first. And the next thing I'm going to do is work on this, right? So let me go ahead and work on this first, and then I'm going to set it equal to that at the end. So we're going to work on this, okay? To do that, I'm going to go ahead and write this as, let's see, I'm going to separate the 7, okay? So write it like this. And then this 7 actually can become an exponent here, which is a good thing, by the way, because now this gives you the same thing twice, which is really cool, right? We don't have e to the t, but we're pretty close. You know how? 7 to the 7 is e to the power ln 7 to the 7, remember? So we're going to replace this with that and switch these two things. So it's going to look like this. W to the power, and I'm going to try to use a different color for that so you can see. Ln 7 to the 7 multiplied by e to the power, and this is where that comes from, e to the power, and I should probably, yeah, I think I'll stick to that. E to the power ln 7 to the 7. Here we go. Now this will be your t, the one in orange, right? This is your new t. You got it? So this is going to become ln 7 to the 7, or you can write it as 7 ln 7. That's the result of the right-hand side. This is the result of the left-hand side. Let's put those together. U times ln 7 equals 7 times ln 7. Ta-da-da-da. Numbers W coming to the rescue, but it took a while. U equals 7. Well, wait a minute. We're not looking for U. We're looking for me. I mean, we're looking for X, right? What is U? U is, let's see. What was U? Oh, U is X plus 2, okay. U is X plus 2, so if X plus 2 is 7, then X is equal to 5. So that should be the solution, and looks like we only have one solution. Could there be another solution? Good question. Let's go ahead and check the second method, okay? But I forgot what the problem is. Okay, I think it was 7 to the power 6 minus X equals X plus 2. Now, Lemmer's W, you noticed, like you've seen how it works, with some manipulations, of course. If you didn't do the substitution, solution would probably be harder. I mean, we could still get a X plus 2 here, but I think substitution is much better, in my opinion. So the second method works like this. Look at 7 to the power 6 minus X. What does that look like? Well, it looks like an exponential function. But guess what? The exponent is negative X, which means as X increases, negative X is going to decrease, and 7 to the power negative X is going to decrease. When X gets bigger and bigger, you're going to have a negatively large power, which means it's going to get smaller. In other words, this is going to be a decreasing function. Great. What about this? This is a polynomial. It's a linear equation with a positive slope, which means that's an increasing function, which means we have two different types of functions here. So one function goes like this, the other goes like this, which means the intersection point is unique. And guess what? We're going to use guess and check. But one thing to keep in mind, the left-hand side is a power of 7. So if you expect X to be an integer, you should try to make sure that this is a power of 7. Or just 7 maybe, right? For example, if X is equal to 5, then the right-hand side is a power of 7. If X is equal to 47, the right-hand side is 49, which is another power of 7, which we could also get 1 over 7, but in which case X would be negative, and that would be kind of problematic, and that wouldn't be an integer, right? But if you think about it, if X is equal to 5, you're going to get 7 to the power 6 minus 5, which is 7. And 5 plus 2 is also 7, which means, indeed, X equals 5 is a solution, and that happens to be the only solution. Normally, I will include a graph, and yay, I didn't forget this time. So the graph shows you where they intersect, and as you can see, one of them is decreasing while the other one is increasing. Therefore, they can only intersect at a single point, which is X equals 5. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out aplusbi, short channel, and bye-bye.